Welcome back, everybody. And welcome to Lena. You've been attending all day, but now it's your turn.
It is.
Yes, I grabbed some candy. It feels like being to the movies. I've heard Lena present a lot of times. She never says the same things. I'm really my utmost respect. I met you several times during my testing careers, and every time I meet you, I get impressed by your knowledge and your skills and the way you structure things. So I'm really looking forward to hearing your speech. And you've been granted extra minutes as the only speaker at this conference. So take it away, Lena.
Yes. So I actually wrote on Twitter this morning that I'm more nervous than I've been for any talk because I'm trying to do something completely different. But let's see, we can start with actually managing to share and see how that goes.
Would you risk it? I can see your screen.
Cool. So why am I nervous? Well, my typical talks are centered along the thought of you have one message and you try to give that message with a few arguments to support it. This talk is going to be something completely different. So if you haven't listened to me or heard about me before, I started out as a developer, did that for 10 to 12 years before I found testing, as so many others. Did a bunch of different testing roles, often around the strategic areas of testing. And then about 5-6 years ago, I turned into the management track, building people instead of software. I am also privileged enough to be able to travel the world to do speaking engagements. I do workshops. I am a blogger, and I'm also, since this summer, an author and a creator of the book, Would You Risk It? And the card deck, Would You Risk It? And this talk is going to be kind of the speed version of this book and this card deck. When I'm not writing, blogging, speaking, I'm an engineering manager at Mentimeter. If you haven't heard about it, it's audience engagement platform, I think is the new area. We aim at allowing people to give more interactive, fun meetings and allow people to collect input anonymously. So it's a cool tool, and you will see it when we do the evaluation today. So what is this Would You Risk It? Well, a few years ago, Lisa Crispin and I said we were going to do a workshop together. And we were discussing different possible topics, and we realized that we were centering them around risk analysis, around heuristics, around patterns. And then, because I'm also a big nerd, I wanted to do some sort of gamification. So what came out of this was a risk analysis workshop and 30 cards, divided into 3 categories with lovely illustrations by Trish Koo. So getting into these cards then, the first categories are tools, and tools can be seen as different types of things that we as testers can use to increase the value of our testing. It could be heuristics, it could be oracles, it could be testing techniques, patterns, anything that skilled testers use, sometimes without even knowing that we are using them. It could also be things like domain knowledge or coaching skills or relationship building skills or system design thinking skills or anything that would actually help us do better testing. I like to think of them as kind of like superpowers that were handed down from tester to tester through either training or literature or mentoring or just plain experience. And we use them to do better testing ourselves, to teach junior testers how to upskill themselves, and also how to communicate better about our testing. And I'm not going to have time to go through all 30 cards, unfortunately, but I'm going to go through a few in each category. And I mentioned heuristics, and heuristics is one of those words that everyone in testing uses, but very few people can explain it in a good way, and neither can I. The best way I've had it described is an approach to solve a problem that is similar to one we know how to solve, but it is not necessarily the same. And my speaking mentor, Maria Chedemo, she uses the metaphor of how to open doors. And we, most of us at least, we open doors all the time, and we know how a door typically works. We know what a lock is, we know what a door handle is, we know what a door frame is. So we have this mental model that we can use to figure out new type of doors when we come across them. So if we are used to the typical Swedish handles that you push down, we can also apply the same knowledge or the same model when we come across doors with like the round doorknob or sliding doors or pull up doors or whatever we come across, because we know what a door is. So we have a heuristic for opening doors. We can also use it for like oracles. So if the door handle is fallen off, we know there's a problem. If the lock shows that the door should be open, but the door is locked, we know there's a problem. And one of the most well-known heuristics is Goldilocks, the too small, too big, and just enough. Another tool that I like to talk about is the forever and never heuristic. So it's said that only SITH deals with absolutes, but I want to say humans do too. We really, really like to apply absolutes to everything. We like to describe things in always and never and black and white. But as testers, we know it's usually not that simple, because absolutes are impossible to verify and the cost can become very, very high. So it's a great skill to have to challenge absolutes when we see it. We also typically like to talk about consistency. We know that we need to be consistent in things we do, consistent within the product, consistent with similar products, with what we claim the product can do, and the image that we want to portray. So if we're doing very serious banking system, we want one look and feel. And if we are doing something very, very fun and creative, we don't want the typical banking looks like it. And there's a very nice UX law that I like to talk about when I talk about consistency, and that's Jacob's law, which can basically be described as users spend most of their time on other sites, not yours. This means that users prefer your site to work the same way as all of the other sites they already know. Which is why if you're gonna try to do the shopping cart with something else than a shopping cart, you should be a bit wary, because we are so used to shopping online and most of the sites work basically the same way. So going away from that behavior and that look can cost us a lot of users. Another tool we can use for testing is we know that users will use the systems in ways it was not intended to use. And we try to guide the users. We can even try to force them to take a certain path, but we know that someone will always find a way around that. And they will expect you to deal with it. So a great tool to have is to talk about how will we deal with the fact that users will not take the straight path up to the top of the hill. And then we make decisions and we test those decisions. Observing is also something that's really important and a great tool in our toolbox. It doesn't matter how you do it or why or when, but we need to look at actual data. And in order to look at data, we need to have access to it. We need to know how to read it, and we need to know what to do with it. So an amazing tool for a tester is learning how to look at data. Things like learning how to read code, learning how to read log files, how to use Google Analytics, talk to customer support, learn monitoring and observability tools, or do user testing. So regardless of how you do the observation, make sure you do the observation and analyze that instead of just making a bunch of assumptions. A tool that I feel a lot of testers don't train enough is being able to articulate and communicate what we are doing and why. I've heard so many people say it looks like we're just monkey testing, just pressing buttons, and they don't understand how we find the problems we find. And I think that's because we don't talk about it enough. Because when we talk about it, we need to actually think about it. And when we think about it, we become aware of the reasons behind why we are doing certain things or making decisions. And then when we become aware of that, we also see when we're strong and where we could improve. And this is something I was really, really bad at for a long time. It was years into my testing careers before I realized that I always defaulted to a certain set of tests for everything. And I did that because my programming background made me aware of where I often made mistakes in the code. So as a tester, I tended to default into testing those things. So I was very strong in that, but I was really, really bad at other things like accessibility testing or performance testing. And as a bonus, when I started talking about what I did and why, the developers actually learned how to do better testing themselves. So they become better developers as a bonus. So we have the tools that we can use to do better testing, but there are also a bunch of traps that we should be aware of as testers. And traps can be seen as common mistakes or anti-patterns that I see testers do. Some of them are, of course, more common in juniors, but some of them are actually increasingly common with seniority because we become complacent. And these traps are a risk to the end quality because our testing will not be as good. And knowing how to identify either what the traps are, which ones we tend to fall into, but most importantly, how to get out of them. All of these increases the value of our work. Because when we fall into a trap, we typically miss like entire areas of testing or types of testing because we are too biased looking for particular problems. And we can use a lot of different things to find these traps. We could work with pairing or mentoring because it's so much easier to see other people's problems. We can take the opportunity to learn how to do self-reflection. Thinking about what did I plan to do? How did I plan to do it? What did I do instead? What did I observe? What did I fail to do? If I missed something, was there a way I could have caught this? And it's important to remember that the goal is always to improve. It's not to blame someone or something. So what could these traps be? Well, misconceptions is my favorite. The things that we believe because we are used to seeing something presented in a certain way. My favorite example, all days have 24 hours. We know 24 hours is a day, right? Well, we know a lot of things that are actually not true. They are just simplified models of reality. And like all models, it's because it would just be too time consuming and energy consuming to consider the entire truth all the time. The problem is that they can cause a lot of problems. It can cause our customers to leave us. It could cause lots of time, money, health, or even lives if we happen to work in the wrong type of software. So time, going back to that example, we have leap days, we know about that. We have 12-hour clocks versus 24-hour clocks. We have time zones, summer, winter time. We have different date formats in different countries, and I'm sure you're all aware of those. But how often do you consider that there are hours that don't exist, or hours that exist twice? Did you know that there are 4-hour clocks or 6-hour clocks? Do you consider that there are different calendars, meaning that we are on different years in different parts of the world? And that's just looking at time. It's such an interesting concept, and it's just a great way of showing that things we know to be true are usually not true. And assumptions, on the other hand, are things we believe without having any proof or any real reason to even believe it. It's just something that is accepted as true. This could be all of the things we read into what people say or what they do because of our experience, our taste, our context. And there's no such thing as a perfect requirement specification, perfect user story. Regardless on how much we try to write things down, there will always be information missing, and we have to make assumptions. It's nothing wrong with making assumptions. We have to do it because otherwise we would never move forward. But what we should do is make these assumptions explicit, become aware of the fact that we are making assumptions. And then we can ask for people's opinion and input and verify or falsify them. And we can learn that other people made other assumptions and realize that something we believed to be true and simple was actually completely the wrong thing, and we hopefully avoid building the wrong product in the end. Another trap we often tend to do, especially when we are running out of time, is that we focus way too much time on the happy path or the positive test. Because of course, we need to make sure that the system does whatever it is we want it to do. But if we only focus on that, we're going to miss out on all of the juicy stuff that can go wrong if you just step out of the trail. And there's also interesting studies showing that negative tests are a lot more efficient at finding bugs. So maybe we should spend more time on them. I don't know about you, but I am definitely guilty of this. I am very much a control freak. I like to understand things. I like to take it apart. I need to understand why something works or doesn't work before I feel safe in my evaluation. Which works great when you work in a 3-year project with 6 months testing periods, but it doesn't work when I need to deploy something to production 40 times a day. I need to learn how to let go. I need to learn that or accept that if the gain of releasing now is higher than the risk of finding more bugs, then I should just let go. If the cost of continuing testing is higher than the probability of finding more things, I should stop. Or, as I'm happy to say is in my case, if we have a lot of safety net in place and confidence that we can fix problems if they are found, I should just let go. One of my favorite traps is the testers get so good at doing one thing that we become kind of a one-trick pony, because finding problems is kind of an endorphin kick. So we want more of that. So we stick to the things that we know work because it makes us feel valuable. The problem is that if we lean too much into that area, we start neglecting other areas because we get so good at this, we let this area fall behind. And trying something new is really, really scary. But in the end, it will make us better testers. Kind of connected to that is the tunnel vision. When we ask our brain to focus too much on one thing, we become kind of blind to other things. So if we are really, really focusing on how a certain button behaves when I press it, we focus so much on that button, we miss other things around it. And the more important we believe that button to be, the less we will see other problems in the surrounding, even if they are obvious. If you've seen the gorilla on a basket field video, you know exactly what I mean. It's amazing. And it can be really tough as a tester to be the bringer of bad news, to stand up for something, especially if you're new, if you're a junior, or if there are very strong voices pushing around you. There's also an art to knowing when do we speak up and when is it better to wait. But ethics is something I talk about a lot, and I believe we have a professional obligation to speak up when we think there is a risk. And just beware, people will try to push us. They might even ask us to lie or hide parts of the truth. And it is our choice if we do so or not. So my encouragement here is, if you think there truly is an important risk, fight for it and push back. And speeding through...
Lena, does aletophobia mean fear of
fear of
bad news?
truth.
Okay, just making sure so I understand your concepts. Thank you.
If I had the tiny little rhyme here, it would be more clear.
Yeah. Well, next time.
Yeah. So I've been speeding through tools and traps because weapons is usually where I tend to get caught up in talking, because I like talking about weapons. Weapons are common developer mistakes, common anti-patterns in code that I have observed in myself, in other developers. It's also typical weak spots in code, like just general. And I think one part why I like talking about this is because I think a lot of testers are weaker in this area, but also because knowing about these makes our testing so much more powerful. It helps us prioritize, it helps us come up with new tests, because there are just some things that are extra complicated to do in code, either because our brain is wired in a certain way, or because computers work in a certain way, or because of just technical limitation and complexity. So they are fantastic things to use as testers, both by figuring out where there might be bigger risk, but also as a way of knowing what questions to ask if we test before there's even code written. One of the ones I think you know about is the borders. We know that the risk for bugs is way higher around the edges. Do you know why? And there are probably millions of reasons why, but three that I want to talk about is the fact that a lot of programming languages start counting from 0 while humans start counting as 1. And if I ask you as a person to count to 7, there's very few of you who would start at 0. But if I ask a computer to count to 7, they will probably win. And the difference between the computer and the human brain makes it easy to make mistakes around everything around that. This is why we have off by 1 errors, for example. The second problem area, or what we call it, is that we do a lot of comparisons in programming. We compare and we have different logical operators, like smaller than, bigger, and or, nor, XOR, all of them. And what we do is we take two things and we compare them and we decide what to do based on the difference between them. And there are many logical operators. They are not used exactly the same way in all languages, but it's also very, very human and easy to make mistakes in either what are we comparing, how do we compare them, and what do we want to do based on the difference. And it's, I mean, I've been doing IT for 20 plus years, and this is still where I find many, many bugs, simply because we do small mistakes around the operators or comparisons. And the third one is ambiguity in rules, business rules, because it's not always obvious how the edges should actually work. People tend to not give examples, they assume something is obvious, but it doesn't matter if there is a right way. People will still manage to interpret things in different ways. So those are 3 reasons why the edges might be riskier than the center. You also probably know about defect clustering, that some areas tend to be more problematic. The bad news is we don't know in advance which areas, but we could guess because we can look at why we tend to have more problems in certain areas. Again, there are many more reasons than what I have time for now, but we have time, money, complexity, and experience as some examples. Time could be that a certain feature was done last and therefore was a bit more rushed. Money could be that we didn't have enough budget to do the solution we wanted, so we had to make do with something less optimal. Complexity could be that a certain part has very complex business rules or very complex programming logic. And experience could be that the developer building a certain thing is not as experienced as the developer building something else, or that we know more about a certain area than we know about something else that's brand new. So when we think about how to prioritize our testing, all of these things are things we can take into consideration. In the book, I have an example, a story from one of my teams where I realized after a while that I was spending way more time on everything a certain developer built. And I didn't even realize it. I just made that risk assessment just based on the fact that I knew there were more problems in previous things they have built. Third weapon I want to talk about is localization, globalization, internationalization. Our software needs to work everywhere it's supposed to be used. And we need to make sure that it can actually do that. And here we are talking about things like either local formats, local rules, local settings, but also local culture. So it could be how we format addresses, character sets. It could be time or date related. It could be how we tend to read through a screen. Do we read from top left to bottom right, or do we read up, down, right, left? How colors and imagery is used and interpreted, we tend to think that everyone is the same as us. So maybe in my culture, red is danger. Maybe in another culture, red is not. It could also be things like, do we use metrics or imperial system for measuring? So this is an area where it tends to be very complex to test, but also complex to make sure that we build the system in the right way. And now I'm going to have to take a breather and take some water because I'm going to move into my 3 favorite cards.
Looking forward to the favorite part. These ones to be good.
Yes. So the juggler is about threading and concurrency. It's a very interesting problem with very interesting pitfalls, with things like race conditions, database locks, and I'm going to try to use a metaphor. So imagine that we have a store and we have 2 customers trying to pay for their groceries. And we can deal with that in a lot of different ways. The easiest thing to do is to have one checkout and users have to just stand in line and we take them in order. The problem is users hate waiting. So how do we typically solve that? We add multiple checkout counters, we add more threads to speed things up. But when we do that, we also add risks. So say that in our fictional stores, 2 customers are wanting to buy the same item, the same physical item. If we, in our computer system, we could either say that the first one who picks it up reserves it until they put it back, which would lock this jacket or apple or whatever it is for all our customers until the first customer puts it back, or before someone moves up to their basket and just grabs it and puts it back on the shelf. So this could be an example of a transaction or a database lock. Another way of going about this is to just let all customers put it in their basket, and then whoever happens to try to check out first gets it. In the best scenario, one customer gets the ware and the other ones just get a bit annoyed, but hey, they just pick up another apple. But if they are trying to pay for the same apple at the same time, we could end up with a race condition where they don't know multiple threads are trying to change the same data at the same time. Or maybe in a potential problem during checkout, one of the apples can't scan, so the cashier needs to look up the price. We can choose to just get up from the register, run to check the price and go back. This is typically how they do it in my store. Very annoying for everyone who has to wait until the cashier gets back. You could also send a runner to look it up, and then you continue with another customer while you wait. This is kind of like asynchronous work. It is quicker for all of the other customers, but you still have to deal with the first customer's wares in a good way, because when the runner comes back, you want to move on with their wares. So juggling all these different threads is very interesting, and there's so many things that go wrong because things become complicated very fast. And then I made a very simplified thing where the checkout is just one single thing, which is what the user thinks it is. All I want to do is check out and pay for my wares. But behind the scenes is likely a chain of things in different parts of the stack. And if one part fails, all of the other parts need to handle this. And these are also different approaches and aspects with benefits and drawbacks. And I mean, if the database fails, how do we inform the user and how do we deal with that? If the credit card fails, how do we deal with that? And I don't expect testers to know all of the different ways you can handle threadings and transactions and different integrations. But what you can do is ask questions around it. What should happen if the database is down? What should happen if the lookup in another system goes down? How do we know if something goes wrong in that application over there that we have no power over? Having these types of conversation is a great way of finding weak points or holes in different solutions. And then all of that needs to be handled gracefully. Users should not be able to crash your system just by trying to bypass whatever you kind of gateways you put up. Code should have proper error handling. It should catch things before they become real problems, and they should let users know what went wrong, and preferably in a way where the user can correct it, but not too helpful, because that's a security risk. And again, errors can occur anywhere. It can occur in the interface or in the API layer or in the database or in another system that's over there. And we need to not only rely on that the entire chain is intact, we need to make sure that we handle all of the different parts. And a lot of us don't do that. We only test through the interface. And there are great reasons for using front-end validations, because they are quick and you can correct problems immediately. It's usually easier for the user to understand, but it's also the easiest for someone to bypass. Back-end validation is fantastic for different business rules, but it's slower and it causes a lot of unnecessary network traffic. And if you went to Samuel's talk this morning, database validation is the thing that's closest to the truth. So it's the most secure, but it's also even slower because data has to travel all the way up and down. And they are often very hard for a user to understand if we send the database errors back up to the user. So there are so many interesting ways we can look at technical complexity and apply that to our testing. So I often say that testers are like the Swiss knives of software development. Really good testers tend to know a little bit about many different things. And we love asking questions, like constantly, to the point where people are like, could you just stop asking questions? And I want you to use the tools you have, beware the traps, and learn some weapon skills. And I hope that this talk has given you some new ideas, maybe a laugh or two, or some inspiration. And regardless of who you are, what your profession is, what your background is, where you want to go in the future, I hope there was something in here for you. Thank you. I didn't need the extra time again.
Right on time. I'm a bit surprised.
Oh, me too.
You managed to squeeze this much information in this time. Very good. Well done. I've learned a lot. I learned Jacob's law. I need to bring that with me in the future, because I've struggled to put wording to that when discussing it. So Jacob's law about users spending more time on your competitor sites than yours, or other sites than yours, and how to make an argument for that. I'm bringing that with me, and a few of the weapons you proposed. And then I just need to train myself to get the weapon skills necessary.
Which I know that you have a lot of them.
Oh, well, it's always need for training. The Hive.
Mm-hmm.
I'm really, I felt you went quite quickly through a broad subject with a lot of pitfalls. What are the main concerns in your opinion? What's specific to look out for?
with clustering.
Yeah.
So I think I rushed through it because I think edge cases and clustering are the ones that testers tend to know most about. So that's why I skimmed over it. Time is the obvious one. This is why we want to do the most complex feature first, because then we have most time for that. And then we can do the less risky thing in the end. But we are always behind on time, aren't we? Like whatever we're building.
Speak for yourself.
Yeah, I'm sorry. In my opinion, we've always been late. So time is the last feature is always the one I feel is most risky. And also kind of a weird one. If you know your team well enough, you know when they are in a bad mental state.
Yeah.
Which means their work will not be as good. So that's something I feel weird about using, but I do. Money is not as often a problem today, but it was 15 years ago when we had to decide on do we save on database space, or do we save on network Wi-Fi speed, or what do we save money on?
Listening to a few of the talks today, there's some struggles still going on in that regard. Yeah,
but I mean, just the fact that one of the first projects I did, the size of images had to be like the perfect balance. They couldn't be too small because then they looked ugly. But if they were too big, the performance just went down. I don't hear people talk about that today. They just put huge pictures up there and it just loads instantly anyway.
One other thing I felt particularly guilty about is the illusionist, because I feel at times I've scratched my back a little bit here. At times I've used that as a kind of the secret testing guild for just to push the value of testing. And you need to be a bit special to do testing. You need the testers have specific skills, and just hiding what we do a little bit to keep that mystery about it. Of course it's bad, and I probably was insecure at the time, but I have been doing it. I must admit I'm guilty to that one. But I think most of the time we do it without realizing people around us don't know as much as we do about it. So we think it's kind of pushing the assumptions onto others instead. Like you have the assumption trap as well. Although we phrase it more beautifully, fool's assumptions.
Yes.
By being the illusionists ourselves, we make the others the fools, making the fools assumptions.
Yeah, and it's interesting that you say you've used it to increase the value of testing, because what I feel is that it kind of devalued the value of testing.
Yeah,
because, since it looked so easy when I did it, people were like, they didn't understand that there were so many complex decisions in my brain going on, like why I went to get a cup of coffee before I finished a transaction, or why I wanted to do it at a certain time of the day, or why I was really excited of going to Finland because then I could test something in like Finnish time zones. So my experience is that once I started talking about it, people saw the value in me in a totally different way.
That's good, but it must be a conscious decision then. So it's good you raised the awareness of it. I also made a quick Google on time zones because I find time a really interesting topic. You know, there's half-hour time zone and even 15 minutes time zones.
No, I didn't. And this is why time is so amazing. It's like,
and there's cultures that don't count weeks. They have 10 days time slots for something they call weekly. So time is really one of the assumptions, cultural assumptions.
Yeah. I mean, just the fact that there are hours that don't exist is just melting my brain.
Yeah.
How can this be?
And skip days and skip seconds, leap seconds, and things like that. Do we have any questions from the audience?
They are still shocked from the speed of my talking.
Well, we have extended your talk 5 minutes past time, so I think we'll leave people to go to the other talks. Thank you very much, Lena. Really,
thank you.
Coming to us and having this talk. And have a good evening.
Yeah, you too. Bye-bye.
Bye. Shutting down the recording here now.